Friends, the topic of analytic geometry, commonly called coordinate geometry, has a big chunk of your mathematics syllabus. What is analytic geometry? Expressing geometrical shapes using algebraic equations. Basically, just that. So, in coordinate geometry, we learn how to use the variables x and y in order to express the behavior of geometrical shapes or the properties of geometrical shapes. We have already studied a little bit of analytic geometry in grade 9 and 10 when we learned how to plot a point on a graph paper, when we have learned how to plot a straight line on a graph paper, and when we have done a few constructions using some of the geometrical instruments. In 11th and 12th, we take this knowledge a notch higher by studying more complicated geometrical shapes. Starting with a bit of revision about what we already know, we will go on to the next geometrical shape, the simplest geometrical curve which is possible, which is a straight line. So, in this chapter, we will study a lot of things about straight lines, picking up from where we have left off in grade 9 and 10. So let us begin the chapter called Straight Lines and Pair of Straight Lines. The most commonly used formula to find out the distance, rather shortest distance possible between 2 points in a plane, is called the distance formula. We have already seen the distance formula. Let's do a recap of the distance formula. Distance between any 2 points in the plane is the length of the line segment joining them. If we have 2 points P, x1, y1 and Q, x2, y2 in Cartesian space, something like this. This is the point P and this is the point Q. Then PQ, the line segment PQ is the shortest distance between these points, and if we call D as the length of this line segment, then D represents the distance between the points P and Q, and this is given by the distance formula. So D, which is equal to PQ, is given by square root of the expression x2 minus x1 the whole square plus y2 minus y1 the whole square. And since these are squares, it doesn't matter what the order of subtraction is. You might as well write the square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. That is, PQ is the square root of the difference of abscissa squared plus the difference of ordinate squared, and that's the distance formula. Next, the area of a triangle given its vertices. That is, we are given the 3 vertices of a triangle, and from that we can calculate the area of the triangle in the plane. Suppose we have a triangle whose vertices are A given by x1, y1, B given by x2, y2 and C given by x3, y3. Then the area of this triangle after various calculations can be simplified as half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This is nothing but the expansion of the determinant given by x1, y1 and 1 in the first row, x2, y2 and 1 second row, and x3, y3 and 1 third row. So the area of a triangle whose vertices are x1, y1, x2, y2 and x3, y3 is equal to half of the value of the determinant formed by the x and y coordinates of the respective vertices of the triangle in each of the three rows of the determinant.